Leigh, you're a planetary scientist that specialises in weather. What have been the most exciting findings from Cassini so far?
I think the incredible thing about Cassini is the longevity, the fact that it has now been there for 13 years in orbit around Saturn. You need to be there for that long, given that this giant planet takes 30 Earth years to go around the Sun. That really means that we've now seen spring, summer, autumn and winter on this enormous giant planet. If I show you some of these images here, which are...
They are beautiful.
Recent photographs from the Cassini spacecraft up there, 1 billion kilometres away in orbit around Saturn. Now, you know on Earth that we have jet streams, okay, that transfer moisture and energy from place to place. Now, jet stream on a giant planet is almost perfectly straight because it doesn't have continents and mountain ranges and things like that to get in the way. So this is another image from the Cassini spacecraft that shows sort of Saturn in all its glory with the rings illuminated just there. And you can see some of these straight jet streams on Saturn's atmosphere. But the really peculiar one is right here at the North Pole.
So I can see something that looks a little hexagonal.
Hexagonal, exactly. What we are seeing there is a jet stream that is meandering. And actually, here's a slightly better view of the hexagon.
It is very hexagonal.
It's wiggling with latitude like a perfect wave in Saturn's atmosphere. We don't fully understand why it's there. We think it has something to do with some sort of instability of the atmosphere, kicking that jet stream. And so this meander has started off and has never ceased in the whole history of the exploration that we've been undertaking. If we move slightly further down in latitude though and go down towards the mid-latitude of Saturn, we move away from that polar vortex, we can see some other fascinating dynamics perturbing that serene appearance. And one such event is actually only happens once every Saturnian year, so once every 30 Earth years. And that is a gargantuan storm system. Punches up.
But it's regular.
It's regular. It seems to happen once every 30 years for reasons that are still sort of unknown to us scientists here on planet Earth. So it takes on this elongated structure just here, like a snake almost, with a head and a tail, because the jet streams are blowing that ammonia ice material around. And actually, in close-up, of course, Cassini has been a wonderful asset to zoom in on the properties of that storm. And this is the head of the storm system that we could see. You can see all the churning eddies and vortices being spawned in this incredibly active environment. If we move now down from the mid-latitudes towards the equator of Saturn, there's actually a lot of interesting stuff that's been taking place down there. You can see in this image, the equator does show up as this anomalous region of higher clouds due to powerful upwelling. What that shows is that a storm event many tens of thousands of kilometres away.
Yeah, because yes, this is, on this scale, because this is Saturn, so it's huge.
Saturn, we're talking 40-odd thousand kilometres between there and there. But the energy that this storm released was able to influence the dynamics there. On Earth, we have a term for that. It's called a teleconnection. It means that meteorology in one location can influence the phenomena that we see elsewhere. And so what Cassini's legacy really is for Saturn is showing how interconnected this planet really is and how the atmosphere responds to weather that's taking place somewhere really geographically separated from it.
So they are interconnected here on Earth and on the scale of Saturn.
And it's showing that all of the beautiful complexity that we see in terrestrial meteorology, from the clouds on small scales up to jet streams and vortices on larger scale, are equally applicable to somewhere like Saturn. So what we thought of as an alien environment with hard to understand phenomena like polar vortices, hexagons, storms and equatorial oscillations, really we can understand all of those if we apply our know-how from the terrestrial climate system. And maybe understanding them in a simple system like Saturn, big ball of gas, will help us to understand them better here on planet Earth as well.